Exercise 3.3 Problem 1 Division 7. Find the zeros of the quadratic polynomial and verify the basic relationship between the zeros and the coefficients 2x square minus 2 root x plus 1. So it's the same problem. So only thing the expression is different here. So p of x, let's p of x be 2x square minus 2 root x plus 1. Now what is the number which needs to be factorized? That is the coefficient of x square into constant. 2 into 1 is 2. 2 needs to be factored in such a way when we add or subtract the factors we should get minus 2 root 2. So 2 can be factorized as minus 2 root 2 into minus 2 root 2. Minus 2 minus 2 root 2 into minus 2 root 2 is 2. At the same time when you add these two you get minus 2 root 2. Okay, minus 2 root 2 minus 2 root 2 is minus 2 root 2. Alright, so the factors are minus 2 root 2 and minus 2 root 2. Now divide this by the coefficient of x square. So this becomes minus 2 root 2 by 2. Doing the same, we get minus 2 root 2 by 2. So this becomes, simplify this, this will be 2 root 2 will go root 2 times. So it is minus 1 by root 2 and minus 1 by root 2. So now the denominator becomes a coefficient of x. So it is minus 2 root 2x and this comes down. So the one factor is root 2x minus 1. And it's the same here, root 2x minus 1. So this polynomial is root 2x minus 1 into root 2x minus 1. Basically it is root 2x minus 1 the whole square. Okay. So now we have to equate it to 0. So p of x is 0 or this is also equal to 0. So root 2x minus 1 into root 2x minus 1 equal to 0. So either this is 0 or this is 0. But both being the same, we can take 1. So root 2x minus 1 is 0 means x will be 1 by root 2 and the second x also will be 1 by root 2 because it's the same expression. Right, now we'll have to check for this 0. So substitute x is equal to 1 by root 2 in this expression. So it is 2x square. So 2 into 1 by root 2 the whole square minus 2 root 2 into x, that is 1 by root 2 plus 1. So what is this? This is half, right? 1 by root 2 the whole square is half. 2 into half is 1. And this is root 2 and root 2 will cancel. So you'll get minus 2 into 1, minus 2 plus 1. So 1 plus 1 is 0, 2 minus 2 is 0. Sorry, 1 plus 1 is 2, 2 minus 2 is 0. So the polynomial, that is p of half, is 0. The same goes for the second because it's the same 1 by root 2. So I don't think we need to redo it. Thus the zeros of the polynomial are 1 by root 2 and 1 by root 2. We have showed it here. Now we'll have to show it in the check the relationship. Okay, before checking we'll have to find the sum of the zeros. What is the sum of the 0? 1 by root 2 plus 1 by root 2 because these are the two roots. Root 2 is the LCM, so 1 plus 1, it is 2 by root 2. Root 2 will go root 2 times. So the sum of the 0 is root 2. What's the product of the roots? 1 by root 2 into 1 by root 2, that is half. Am I right? Next, the sum of the zeros for the polynomial is given by a negative coefficient of x divided by coefficient of x square. So what is the polynomial? It is 2x square minus 2 root x plus 1. Coefficient of x is minus 2 root 2. Coefficient of x square is 2. Putting that value, what will you get? Minus of coefficient of x, which is minus 2 root 2 divided by coefficient of x square. This will become plus, so it will be 2 root 2 by 2. This 2 and 2 will cancel and that is root 2. You can see we are getting sum of the roots as root 2 by expression and by our calculation we are getting it as root 2. So both are right. Next we will have to check for product of the zeros, that is given by constant term divided by coefficient of x square. So what's the constant term here? That is 1. Coefficient of x square is 2. So it is half. And you can see that's the same which is obtained here also. So the sum of the zeros and the product of the zeros are same when we calculate it by the zeros, when you actually find out the sum of the zeros and the product of the zeros using the actual zero values, which means the zeros of the polynomial are 1 by root 2 and 1 by root 2 is right. Okay, so I hope I've cleared it. If not, please go through this video one more time, it will become clear. Thanks for watching this video.